This past couple days we've been working with series of pictures and trying to explore patterns in series. For example, here's figure 1. Ooh, is it figure 1 or is it just an eye? Well, let's see. Here's figure 2. Here's figure 3. Alright. I'll bet you know what figure 4 is going to look like. Now, of course, there are not 8 dots here. You can count them. 1, 2, 3, 4, 5, 6, 7. No? Okay. The question is how can we look at this and come up with number patterns, etc. Now this one actually, if we look at these numbers, he's like, oh well, look at that. That's easy. All right, and maybe we can just determine a relationship between this number and that number by just looking at the numbers. And if you can, very good. All right, because that ultimately is our goal, is to be proficient so that we can look at this pattern of numbers and we can come up with formulas. But we should also be able to look at this story, this picture. We should be able to go from the picture series, not just the number patterns, but actually, you know, here's our thing that we're trying to model numerically. And we want to be able to write a variable expression ultimately for this. So what sort of things can we do to break this up? Well, let's see. How many dots do we have here? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Oh, well, this is figure 5. And, you know, what sort of... Where can we find the number 5 in this picture? Well, we can find the number 5 right here. And we can find the number 5 right here. Well, there you go. That's 5 plus 5 is 10. But no, it isn't, because this guy's been counted twice. All right, so we have to undo counting that twice. We counted it first with the bottom one, then with the top one. We want to count it one of those 2 times, not both of those times. So we're going to subtract 1. And so we did 5 plus 5 minus 1, or you could write that 2 times 5 minus 1 if you want it. All right. And then it's on to our theoretical figure n. And we're looking at figure n, and it's like, well, if we look at this idea, how many dots would this be here? Well, it's 5, right? So this is n. And how many dots? Well, you see the relationship there. It's going to be n. So that's n plus n. And again, we had to do that minus 1. Okay, we've counted that same thing twice again. Or again, 2 times n minus 1, or if you want to be slick, 2n minus 1. Another way to group those same 5 dots, 1, 2, 3, 4, 5, 1, 2, 3, 4. Well, I guess I just said the other way to group those dots, is to see 5 going the one way and only 4 left going the other. This is still figure 5. Let's see, let's explore figure 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Oh yeah, 6 and 5. So, sure looks like it works. So, here's our figure n. What's that going to be? Nope. No. It's going to be the same as the figure number. And the figure number is no longer 5. The figure number is n. And that's 1 less than n. How do we write 1 less than n? So that's n plus n minus 1. Hey. Here it was n plus n, and then we did minus 1. And here it's n plus 1 less than n. Isn't that fun? There, you can see it now. And n, they're like separate. And then the 1 is like an afterthought. And here, the 1 is part of this. But yet at the same time, it's n plus n minus 1, which, we can still take that and turn it into 2 times n minus 1. How about that? So then we started talking about that triangular shape. And let's just speed things up and say here is figure 5. 5 dots this way, 5 dots that way, 5 dots that way. How many dots? Well, it was 5 dots, 5 dots, and 5 dots, right? Well, that would be 15. Except we counted all 3 of those twice. Oh, I almost forgot. Figure n. What will this be? N. Uh-oh. That looks like 3n minus n. 3 n's, n times 3. Then we've got still those same, always minus 3. Yeah, 3n minus 3. All right. Now the triangle's fun because there's a bunch of ways you can break it up. You can go 5, 4, 3. And 5 plus 4 plus 3, by the way, 9 plus 3 is 12. All right. It's like 15 minus 3 is 12. And then that's n, and that's n minus 1, and that's n minus 2. So you've got n plus n minus 1 plus n minus 2. And more n. That's 3 n's. Take away 1, take away 2 more, take away 3. That looks awfully familiar. Ooh, 3n minus the 3. Again, the minus 3 is for a different reason this time. Yeah. All right, let's see. There was another really cool one. I think this one's pretty. This is figure 5, but that's 4, 4, and 4. Yeah, 4 times 3, that's 12, just like the other times. That's 12. And what I got here, this is 1 less than n, and so is this, and so is this, okay? So that's 3 times n minus 1. Notice we can use the distributive property there. 3 times n is 3n. 3 negative 1. 3 times negative 1 is negative 3. Ooh! Yet another magic way to get that minus 3. That's what we've been doing. Hope you had fun.